All right, let's crush this Sudoku. This one's called Count to 10 by Gerhard, 1963. So normal Sudoku rules apply. We got the digits 1 through 6 in every row, column, and 2x3 box. And then we got counting cages. I don't know if I'm familiar with these. Any digit n that appears in any green cage must appear in n green cages. Digits may not repeat within a cage. So if there's a 4 in here, we'd have to have a 4 in 4 of the cages. How many cages are there? 1, 2, 3, 4, 5, 6. So we could have a 6 in... No, we couldn't. Okay. But that's probably logic I can save. I guess we could have a 6, because 6 could be the only number in both of these single cell cages. But then the biggest number that we could have would be a 4. Okay, there's probably a lot of logic there. X pairs. Digits in cells separated by an X sum to 10. Not all possible X's are necessarily given. Well, that's a big deal in this puzzle because there's only one way to make 10. We'll get to that as well. Kropke pairs. Digits in cells separated by a white dot are consecutive, not necessarily all dots are given. So three of those. All right, so these have to be 6, 4. Because we can't have 5, 5 on an X, and there are no other numbers big enough to add 10. So these two things are 6, 4. Which then tells me that 6 can't go in this cage, so 6 is eliminated from these cages. It would also be very hard to put 4 in the cages. So 4 would have to go. 4 would have to be both of these. Because 4 can't go in this cage, because it's in one of these two squares. If we're going to put 4 in a cage, it would have to be both of these. And it would have to go. It would definitely have to be in both of these. Because if it's in one of these, it has to be in both, right? Am I wrong about that? I guess I'm probably wrong about that, actually. 4 could just go in one of these cages. And then, yeah, because there are 5 cages left that 4 could go in. For some reason, I was thinking it had to go in both, and that's not true. All right, these are 4, 6, though. So 4, 6 in this row has to go in this top 3 here. So it has to go in these two. Because 4 and 6 are looking at this. And we have our 4, 6 for from this row in this box. So it can't be these, can't be this one. So this is a 4, 6 pair, which is interesting. So either 4 or 6 is going in the box, and it can't be 6. Okay, there we go. Yeah, so I already said 6 can't go in the boxes because every single, like these two boxes there are only 6 boxes. So if 6 can't go in this one, it can't go in any of them. So this one is a 4. This one is a 6, and we're off. And we're off, dude. So this can't be a 4. So now three of these last 4 cages need a 4. This can't be a 6 because 6 can't go in the cages. So this has to be a 4. Okay, I could have had that before as well. Okay, 4, 4. One of these two has to be a 4. One of these has to be a 6. So if 4 has to go in this cage, it has to go here. I don't know that that's the case yet, though. Oh, and this is also telling me that 1, 2, 3, and 5. So these numbers are 1, 2, 3, and 5, which means 5 goes in the cages, and this one's a 4. So 5 has to go in the rest of them. So, all right, I'm gonna 1, 2, 3, 5. And since 5 has to go in this cage, that means it has to be in 5 different cages, and we only have 5 different cages left after we put a 4 in here. So this can't be a 4, which means that this has to be a 4. All right, so there's going to be a lot of logic associated there. So because we know that 5 goes in the cage, I don't know how that's going to work out. I don't know where it goes in any of the cages except for this one. This one absolutely has to be a 5 because there are only 5 cages left, and there has to be a 5 in 5 cages. So this one has to be a 5, which means this one has to be a 4. So 5 is in one of the... Oh, well, this one... Now that this one's a 5, there's only 4 cages that could have 4. There's only 3 cages... I guess there's only 2 cages that could have 4s left. And they have to have 4s to make 4 cages with 4s because this one can't. So this is a 4. Now this is a 5 because 5 cages need 5s. So now this isn't a 5. Which means one of these is a 5. Oh, it's this, because this cage needs a 5. This cage needs a 5. One of these two is a 5. And we're moving, dude. We're moving. Have I placed a 5 here? Yeah, this is a 5. Alright, only one cage can have a 1, and it's this one. So I know 1 doesn't go in any of these other cages. Is that helpful at all? That means 1 has to go in one of these two. which means one of these two is a 2. So now 1 has to go in one of these two. All right, what are the numbers here? 2, 3, 1, 2, 3. Not helpful. So 2 is going to have to go in exactly 2 cages. Oh, 3. Okay, there it is. Okay, so there's enough cages filled up. We need 3s. We need 3s in 3 cages. One of them is going to be in there, and then we only have 2 cages left to fill. And this only has 1 cell, so this is definitely a 3, which makes this a 2 because it can't be a 4, and these are consecutive, which makes this a 1, which makes this a 2, which makes this a 3. These two numbers are 1, 6. I don't think I have that figured out yet. This is a 3. Only number left in the column. So these are 1, 2. I don't think I know which one yet. Okay, so I've got nothing from this entire box. We need a 3, and now we need a 2 and a 4. 3 has to go in one of these two. 2's in one of these. 4. So these have to be consecutive. Is that what's going to straighten this out? Oh, 4, no, 4 is placed. 4 is here. So this is a 4. So this is either a 3 or a 5, and 5 has to go down here. So this is a 3. Now this is a 2. This is a 5. 1, 6. Do I really not have that straightened out? These are just 1, 6. No, because one of these two has to be a 6. Now, does it not? Yeah, it does. Yeah, one of these definitely has to be a 6. Okay, so this is a 1. This is a 6, and also 6 couldn't have gone here, so that would have been useful as well. So neither of these are 3. So this is a 1, 2 pair, which means this is a 3, 5 pair, which means this is a 3. This is a 5. Oh boy. All right, what else we got here? Oh, this must be straightened out. Yeah, okay. 6 here, 6 here, 4 here, 1 here. What numbers do I need down here? 1 has to be in one of those two. 2 has to be in one of those two. What are these two numbers? Oh, we have a 6. Okay, 6 here. So this is a 2. So this is a. We need a 1 and a 2. We need a 1 and a 3. This is a 3. This is a 1. 3 in the corner, dude. 3 in the spotlight. 2 there. 1 there. 2 there. 1 there. And that's a Doku smash, dude. Smash that Doku, dude. There it is. Thanks for watching. Catch you later.